the video lecture series on this digital signal processing. Coming on to analog, discrete time, and digital sign signal in time domain. Analog signal is continuous in time and amplitude. The same analog signal, when it is captured at frequent intervals of time, then we'll be getting the discrete time signal. The discrete value on quantization and encoding, we'll get a digital signal. It is a finite level signal. If it is 2 bit, single bit it is at 0 and 1, 2 bit 0 0 to 1 1, 3 bit 0 0 0 to 1 1 1. So the same signal can be represented in all the three forms. Based upon the mathematical analysis, we select the different forms of representation. Next thing which we have to know is time domain and frequency domain. The same signal, it is represented in both the domains. Time domain, it may be in radians or degree. Degree is the thing which we normally use: 0, 90, 180, 270, 360, we all know it. Radians is nothing but the ratio of arc length to the radius, which is also used mathematically to process the signals, because it is easy to handle mathematical operations like differentiation when it is in radians rather than using it directly in the degree. Next, coming on to the frequency domain, same signal has signal processing circuit. Usually, they will be taken care, designed based upon time domain and frequency domain. We'll be designing the processing circuit such that it works for different frequencies and different time domain. So same, for example, in the signal shown, that is x of t equal to a sin omega t, that is represented here. If the frequency is 500 hertz, if not, for example, a single straight line will be there. If two sine signals, two frequencies is there, then it will be 500 and 1000 hertz. It will be represented as a single straight line in the frequency domain, that is linear domain. If it is in circular domain, the representation will be from 0 to 2 pi. Here, it is circular in notion. Omega is 2 pi f, we all know it. Here, when we use mathematically, the limits are always from 0 to 2 pi. Coming on to the transforms that are used in digital signal processing, we all know about continuous time linear time invariant system as well as discrete time linear time invariant system. Usually, Laplace transform is used for time domain to frequency domain conversion. Laplace is represented in S domain. Discrete time signals are always handled mostly using Z transform. Here, the time domain to frequency domain conversion happens using the Z transform. Some of the notations that is practically used in designing using Z transform and Fourier transforms are n discrete samples in time domain. X of n is the discrete time signal. Capital N always represent the number of points. F represent the discrete frequency, omega 2 pi f, that is in radians. K is discrete frequency samples. X of k is frequency response. Magnitude response is modulus of x of k. Phase response is angle of x of k. Z is equal to r e per j omega. This is the relationship of Z. Coming on to Z transform, it is a complex variable. It is given by Z is equal to R e power j omega. While representing in pictorially, it is represented in circular plane, whereas x-axis represent the real part and y-axis represent the imaginary part. Omega is the angular frequency, R is the radiance here. Coming on to the signals, discrete time signals, it is represented like this. X of n is equal to 6, 18, 12, 20, 6, 7. This means that the sample values 6, 18, 12, 20, 6, 7 are values. The arrowhead represents the reference plane. It is always n value is 0. When the arrowhead represents n is equal to 0, at n is equal to 0 instant, the value is 6. At n is equal to 1, the value is 18. At n is equal to 2, the value is 2. So right side sequence, it will be available in the positive axis, whereas in the left side sequence, the values will be available in the left side, negative axis. Again here, the arrowhead represents the reference plane, that is 0, and minus 1 at the negative axis, the value is 9, minus 2, the value is 5. So left side sequence is represented like this. The two-sided sequence here, 6 again, the arrowhead with reference 0 reference, it has both the right side and left side sequence. So this diagram clearly depicts the all the three-sided sequence, right, left, and two-sided. Signal appears only in the right side, that is positive axis. It is right-sided for n greater than or equal to 0, whereas left-sided n less than 0. 0 will come under right side. This is to be noted. Similarly, two-sided, it has both. So this is the same signal in the frequency domain if it is represented using omega and x of e per j omega. You can see the frequency domain representation. So in this video, we have seen about what an analog signal, what a discrete signal, and what a digital signal is, and how it will be represented. Similarly, why time and frequency domain is needed, and how it is represented. And to start with Z transform, how it is circular represented in circular frame, and the types of sequence usually available in signals, that is right sided, left sided, two sided. All those things are represented here.